Now, a Newport Pagnell-based firm which has invented revolutionary new breast cancer diagnostic technology has been awarded a prestigious business award by the Institute of Physics. Digistain say its technology, which has already been adopted in hospitals in the US and India, could save thousands of lives and potentially save the NHS over £1 billion a year. Dr. Hemmel Amrania is a clinical scientist and CEO of Digistain, and he joins me in the studio. Good evening, Doctor. Welcome to the show.
Hello, Fazana. Thank you for having me on.
Now, look, first up, congratulations on this award. Brilliant news. Now, look, for the non-scientists amongst us, just tell us in simple layman's kind of like technology, what is this technology?
Sure. So what we do is we analyse a tumour biopsy from breast cancer to help the physician decide if the patient needs chemotherapy.
Right.
In a nutshell, that's what we do.
Okay.
And what we've done is we've really tapped into recent advances in computing, AI, that kind of thing, to make this happen.
Yeah, because at the moment, what is the situation at the moment? It's a lengthy wait, isn't it?
Yeah, thanks for bringing that up,
testing.
Fazana. So people, at the moment, after surgery, patients are waiting several weeks to get the results back before they can even have any indication about what kind of therapy they're going to be facing. And that's, I think, what's not spoken about often enough is the sheer stress and the agony of that wait. I mean, I've lost... I'm sure every family here has been touched by breast cancer, but I think it's just insane that here we are today in 2022, and we're sending samples off all the way across the world to the USA
for analysis. Exactly, yeah. And you know the impact on you when you want to know what your next treatment option is going to be, and you're planning things. You may be juggling family commitments, etc. So no, completely. Now you say this technology could potentially save the NHS billions of pounds a year. How can tell me about that?
Sure. So when you do the maths, chemotherapy is a massive cost centre for the NHS, and when you've got, we're just sort of scratching the surface here with breast cancer. Ultimately, our vision is to find indications in prostate cancer, lung cancer, colon cancer, all of which, for which we've done proof of concept studies already. And when you do the maths and you work out how much chemotherapy can be saved with a simple test like this, it's in the mega millions and all the way up to $1 billion.
Yeah, no, I mean, you mentioned some of the cancers there. Would this also be effective for brain tumour research?
Yeah, any
as well,
solid tumour, basically.
Yeah.
Any solid tumour.
No, brilliant. Now, look, this technology is already being used in hospitals in the USA and India. What are some of the barriers to it being used by the NHS?
Yeah, so look, the NHS, I mean, whilst they're doing a fantastic job, it is probably one of the biggest employers in the world. So you can imagine there's going to be a degree of inertia to try and effectuate any kind of behaviour change, particularly in a very, rightly so, conservative segment like physicians, So, fortunately, we've been already approached by the NHS to start helping patients in the Midlands area already. Brilliant. So now the challenge is getting wide-scale adoption across the UK. But I'm glad you brought that up because we are already available, and there are, world-class institutes in India and the USA who are already using Digistain.
Yeah, and how easy is it to set up this technology? I mean, it's artificial intelligence. Well, just so we can actually visualise this technology, because it's the screening, isn't it? It's the screening.
Yeah. So what we do is, unlike at the moment where samples are being shipped all the way across the world into a single laboratory, what we're doing is bringing that capability right to the hospital who needs that diagnosis, within an hour or so.
Brilliant. And I was reading some of the stats. You can it's just a so much quicker, cheaper way of identifying patients who can safely avoid chemotherapy with more than 99% accuracy. That's phenomenal.
Yeah, it is. Yeah, and I think our mission was always to try and eliminate that inequality of care, because whilst these samples are being shipped off all the way to the US, it's incredibly expensive. And what that means is there are marginalised communities around the world, in India, in Africa, that we're now helping in a way that it's never been done before, because they can't afford these $4,000 tests.
Yeah. Yeah.
So that's a problem we're solving.
Yeah. What were some of the barriers towards developing this technology? I mean, was this technology always there? Just talk me through some of the barriers.
Sure. So I've got a physics and maths background, and I think...
your parents must be so proud.
Well, there you go, Asian parents, right? So I think what's been challenging is what happens in science is that people work with analytical techniques that they're familiar with. So chemists work with the routine techniques that they're familiar with, and then biologists with their techniques. And then with physics, what we've done, I think, is we bridged that gap between physics and medicine quite successfully. And I think I'm glad you brought that up, because what's really difficult to achieve is translation of laboratory research from the research environment to actual clinical utility. And I think that's that chasm that we bridged successfully and very quickly as well.
Yeah, no, which is brilliant. I mean, my background is microbiology. So,
Sure.
I mean, when I was studying many decades ago, we didn't really have rapid kind of technology to identify key species and things. And that's been something that's been phenomenal. That has just completely revolutionised not only the manufacture of things like sterile products, etc., but also just as a diagnostic tool as well. So, I mean, I get quite excited, because I think, what will the future look like in 5 years, 10 years? What can we actually be capable of as well?
It's incredible, yeah. I mean, the advances now, thanks to computing, of course. There's so much more available, and I don't need to tell you that there's so much research out there with genomics, which is opening up, so much insight for disease discovery and disease treatments and things like that.
Yeah, no, brilliant. So, what's the what's your firm working on at the moment? Is there anything kind of in development that you can talk about, that you can let us know?
Yeah, so at the moment, we've already got MHRA clearance for helping physicians decide if their breast cancer patients need chemotherapy or not, or whether they can avoid it. But we've just won an Innovate UK award for doing further research in other indications as well. So we've got prostate cancer studies that we're doing, we've got colon cancer studies that we're doing. So we're moving at a really fast pace, and I think we have to, for social reasons, and also because there's a lot of stress, particularly in the UK, with innovative companies now, because we are a company now, to survive. Otherwise, if they don't get adoption quickly, then a lot of promising technologies just fall by the wayside. Exactly.
So this technology, I mean, it's been rolled out in the Midlands, you said, and then any plans to kind of roll it out maybe, down south, further up north?
Yeah, so we're working with the NHS right now to start to get wide-scale adoption around the north, in Wales, and also down in the south in London as well. Yeah,
and you must have heard some really heartwarming stories from breast cancer survivors, from maybe patients who thought, if we had this technology, it could have really helped them, in terms of their treatment, etc. Tell me about some of the heartwarming stories.
Oh, yeah, sure. So I think I'm glad you brought that up, because this brings this home, really, because at the end of the day, what we're doing is trying to vie for social change here, and talking about these topics when you're with physicians, I think the whole medical profession gets quite desensitized, because they're dealing with these cases on a daily basis. But at an individual level, it's incredibly stressful for patients to deal with the agony of waiting to figure out whether they've got cancer, what kind of surgery they're going to have, what kind of treatment they're going to have. And I've been blessed to have spoken to hundreds of patients, survivors as well, and really happy to have their support here as well, because their voice matters, frankly.
Yeah, of course. Of course it does.
But I mean, I think there was a documentary last year by Julia Bradbury who really captured, I think very faithfully, the individual stress and agony that someone has to face because of the waiting. Yeah. And I think this rarely gets spoken about in the medical profession.
Yeah, no, I mean, 3-4 weeks, that's a long time. That's a long time when you're waiting.
So, Fazana, in India, where we're helping communities there, people are often waiting 6 weeks for their results.
Wow.
And those same patients we're helping within 2 days.
Yeah, no, it's just incredible. You just
Yeah.
can't put a price on that, can you, really? Look, Dr. Hemmel, thank you so much for joining us. You're always welcome on the show. Do come back again and chat to us.
It's been a
Thank you
pleasure.
so much.
Thank you for having me on,
You
Susanna.
take care. You take care.